How are steel made? I am complete guide you about it. Now, how many particles made and of steel create? So in this topic, I am complete teach you about it. But first of all, if you are new, so please subscribe my channel, press the bell icon. So I have start my topic about steel. So I have start. Steel is an alloy of iron and carbon with improved strength and fracture resistance compared to other forms of iron. Because of its high tensile strength and low cost, steel is one of the most commonly formed and is resistant compared to other forms of iron. Because its high tensile strength and low cost, steel is one of the most commonly manufactured materials in the world. Steel is used in buildings as concentrate reinforcing rods in bridge infrastructure, tools, ships, trains, cars, bicycles, machines, electrical appliances, and furniture and weapons. Iron is also the main element in steel, but many other elements may be present or added. Stainless steels, which are resistant to corrosion to oxidation, typically need an additional 11% chromium. Iron is the base metal of steel. Depending on the temperature, it can take two crystalline forms, allotropic forms, and body-centered cubic and face-centered cubic. The interaction of the allotropes of iron with the alloying elements, primarily carbon, gives steel and cast iron their range of unique properties. In pure iron, the crystal structure has relatively little resistance of the iron atoms spilling past one another, and so pure iron is quite ductile or soft and easily formed. In steel, small amounts of carbon, other elements, and inclusions within the iron act as hand-draining agents that prevent the movement of dislocations. The carbon in typical steel alloys may contribute up to 2.14% of its weight. The carbon in typical steel alloys may contribute up to 2.14% of its weight. Varying the amount of carbon and many other alloying elements, as well as controlling their chemical and physical makeup in the finer steel, either as solute elements or as precipitated phases, impedes the movement of the dislocation that make pure iron ductile and thus controls and enhance its qualities. These qualities include the hardness and quenching behavior, need of annealing, temperature behavior, yield strength, and tensile strength of the resulting steel. The increase in steel's strength to compare to pure iron is possible only by reducing iron ductile. Steel was produced in blowmery furnaces of thousands of years, but its large-scale industrial use began only after more efficient production methods were developed in the 17th century with the introduction of the blast furnace and production of crucible steel. This was followed by the Bessemer process in England in the mid-19th century, and then by the open hearth furnace. With the invention of the Bessemer process, a new era of mass-produced steel began. Mild steel replaced wrought iron. The German states were the major steel producer in Europe in the 19th century. American steel production was centered in and Europe in the 19th century. American steel production was centered in Pittsburgh and Bethlehem and Pennsylvania and Cleveland until the late 20th century. Currently, world steel production is centered in China, which produced 54% of the world steel in 2023. Further refinements in the process, such as basic oxygen steel making (BOS), largely replace earlier methods by further lowering the cost of production and increasing the quality of the final product. Today, more than 1.6 billion tons of steel is produced annually. Modern steel is generally identified by various grades defined by assorted standards organization. The modern steel industry is one of the largest manufacturing industries in the world, but also one of the most energy and greenhouse gas emission intense industries, contributing 8% of global emissions. However, steel is also very durable. It is one of the world's most recycled material with a recycling rate of over 60% globally. Definitions and related materials which made and create a steel. The non-steel originates from the Proto-Germanic objective "Tahlija" or "Tachlijan", made of steel, which is related to "Stalace" or "Talija" standing film. The carbon content of steel is between 0.02% and 2.14% by weight. For plain carbon steel, iron carbon alloys too little carbon content, leaves pure iron quite soft, ductile and weak. Carbon content higher than those of steel maker a brittle alloy commonly called pig iron. Alloy steel is the steel to which other alloying elements have been intentionally added to modify the characteristics of steel. Common alloying elements include manganese, nickel, chromium, molybdenum, boron, titanium, vanadium, tungsten, cobalt, and niobium. Additional elements more frequently considered undesirable are also important in steel: phosphorus, sulfur, silicon, and traces of oxygen, nitrogen, and copper. Plain carbon iron alloys with a higher than 2.1% carbon content are known as cast iron. With modern steelmaking techniques such as powdered metal forming, it is possible to make very high carbon and other alloy material steels, but such are not common. Cast iron is not malleable even when hot, but it can be formed by casting as it has a lower melting point than steel and good castability of properties. Contain composition of cast iron while retaining the economies of melting and casting can be heat treated after casting to make malleable iron and ductile iron objects. Steel is distinguishable from wrought iron, now largely obsolete. Allahu Akbar. So now start again, which may contain a small amount of carbon but large amount of slag. Material properties and origins and production. Iron is commonly found in the earth crust in the form of an ore, usually an iron oxide such as magnetite or hematite. Iron is extracted from iron ore by removing the oxygen through its combination with the preferred chemical partners such as carbon, which is then lost to atmosphere as carbon dioxide. This process, known as melting, was first applied to metals with low melting points such as tin, which melts at about 250 degrees C and 482 degrees F, and copper, with melts at about 1100 degrees C and 2010 degrees F, and the combination bronze, which has a melting point lower than 1083 degrees C and 1981 degrees F. In comparison, cast iron melts at about 1375 degrees C and 2507 degrees F. Small quantities of iron were smelted in ancient times in the solid state by heating the ore in the charcoal fire and then welding the clumps together with the hammer, and in the process squeezing out of the impurities with care. The carbon content could be controlled by moving it around in the fire. Unlike copper and tin, liquid or solid, iron dissolves carbon quite carbon it is. All of those temperature could be reached with ancient methods used since the Bronze Age. Since the oxidation rate of iron increased rapidly beyond 800 degrees C and 1470 degrees F, it is important that smelting take place in a low oxygen environment. Smelting using carbon to reduce iron oxides results in an alloy pig iron that retains too much carbon to be cast steel. The excess carbon and other impurities are removed in the subsequent step, and other materials are often added to the iron carbon mixture to produce steel and desired properties. Nickel and manganese in steel add to its tensile strength and make the austenite from the